Yes, it's an interesting heading. F dash x times function x to the power of n. What this basically is, some people call it the reverse chain rule. You see, if you've got your integral set up, and you notice that's what you've got some function to the power of n, but the derivative of that function is out the front, so it's set up like that. Essentially, you've just used the chain rule to get that answer, because what would we have done to get the chain rule? If I was differentiating function x to the power of n plus 1, I would have bring down the power, so n plus 1 would have come out the front, lower the power, n plus n would have been n, times the derivative of the inside. So if we're going back the other way, that's essentially what we got, but I've now got to just divide it by that power. It's sort of like add 1 to the power over the power. Same idea. Now, sometimes you see questions where they give you huge hints. They'll say, oh, hey, how about you go and find this derivative? Oh, okay, let's go find it. If I differentiate that, I've got to use the chain rule, bring down the power, lower the power, diff the inside, I'll put it back into surd form. There it is. I wonder why they asked me to do that. Because they follow it up with a question like this. Hence go and find this integral. You go, hang on, look what I just did. That's why taking it out of the index form is good, because when I see it like that, I go, that's essentially the same thing. It's only differing by a constant value. All right, well, let's write that. See, if you had asked me this question, minus 3x squared on 2 root 1 minus x squared, I'd know the answer straight away, because I just worked out that when I differentiate the square root of 1 minus x cubed, I get that. Therefore, if I integrate minus 3x squared on 2 root 1 minus x cubed, I must go back to root 1 minus x cubed. Well, I can't change the question, so to balance it out, I'll now multiply the whole thing by minus 2/3. They are now equal statements. But remember, we know the answer to this integral, therefore, the whole integral is that. And that essentially is the idea behind that rule. But as I say, they've just given us a huge hint about it. So if they don't give me that hint, and they simply say, hey, integrate this, what's causing me the problem? That's what I like to look at when I'm seeing these sort of integrals. What's causing me the problem? And what's causing me the problem is this square root sign, 2 plus x squared. I can't expand out to the power of a half or anything like that. So that's causing me the problem. What would be really nice is if I had the derivative of that there. And, well, I haven't quite got it. I've got x. So what would have been nice is if I had 2x, because now I've got it set up of the derivative times some function to a power. Can't change the question, of course, so balance it out with the half out the front, and now, because it's in that form, derivative times the function, I can just go, well, let's add 1 to the power over the power. Half times 2/3 will tidy up, bang, we've got our answer. Now, there is another technique, which we'll look at in far more detail next year, called integration by substitution. It's still the same idea, but it has a bit more working out to it. It's probably not as efficient. If you spot it straight away, it's so much quicker. But if you don't, you go, what's causing me the problem? Well, that's 2 plus x squared. So let's make 2 plus x squared go away. I'll change it into something else. So I'll change it into u. But I can't just change one thing. I've got to change everywhere I see x has got to change, and that includes the dx. That's got to go away as well. Well, I could differentiate u, and I get du dx is 2x, and I mean, technically that's not a fraction. Du dx is not a fraction, but it is a rate. So I can think of it like a fraction and rewrite it like this, and say, well, du then is the same as 2x dx, which allows me now to substitute back into here. Because I say, oh, hang on, 2 plus x squared, that's what I made u. I made it go away. But the x dx, well, that's half of what I'm saying du is. I can now rewrite my question into a much simpler integration. It's a half the integral of u to the power of a half. Okay, I'll add 1 to the power over the power, but of course, u is the pronumeral I introduced. I now have to substitute back in for u 2 plus x squared, and we get our answer. That's the idea of integration by substitution. Let's say, bit more working out to do if you don't notice derivative times function straight away, but it works. Let's try it on this one. This one's a definite integral. So there's yet another thing we have to do with the substitution method. But first of all, let's look at that. What's caused me the problem? Oh man, look at this thing on the bottom of the fraction. X cubed minus 2 to the power of 3. I can't expand out x cubed minus 2 to the power of negative 3. That's causing me the problem. Wouldn't it be nice if I had the derivative of x cubed minus 2 somewhere? Well, I do. The top of the fraction, I can change to 3x squared. Now I've got derivative times some function to the power. Beautiful. I can add 1 to the power over the power. We get our answer once we substitute in. If I was to use the substitution idea, again, I'd go, oh, what's causing me the problem? X cubed minus 2, let's make it go away. U is x cubed minus 2. You notice I didn't bother writing du dx equals, I just straight away went to du is 3x squared dx. That's what I'm going to substitute in. So now, but hang on a sec. Remember I said there's something a little bit extra we have to do for substitution here? Because those limits are also referring to x, not to u. So I've got to change those limits as well. But I've got a formula. U equals x cubed minus 2. So when x equals 0, u is negative 2. But when x is 1, u is negative 1. I can now change my integral into something a lot simpler. Add 1 to the power over the power. But here's one of the advantages, I guess, of the substitution method. I now, because it's a definite integral, I now don't have to substitute back in for u or the x's, because my final answer is going to be a number. It's not going to involve x. So I can actually just substitute into here, and we get our answer of minus 1/8. And that shall do us.